Compound and continuous interest. For this video and videos similar to these, visit the website www.atcmathprof.com. Here we have the compound interest formula, and the formula for compound interest, which is the interest paid on both the principal and the interest, is an important application of exponential functions. Suppose that a principal of P dollars is invested at an annual rate R, which is in decimal form, compounding N times per year. Then the amount A accumulated after T years is given by the formula. A is equal to P times the quantity 1 plus R divided by N raised to the N times T power. And in this formula we have P, which is the principal or the initial investment, R, which is the annual interest rate, which is in decimal form. We have N, which is the number of compoundings per year, and we also have T, which is the time in years. Let's take a look at an example. In this example, suppose that $1,000 is invested at an annual rate of 4% compounded quarterly. Find the total amount in the account after 10 years if no withdrawals are made. Here's the solution. We can see from the given information that P, which is the principal, is $1,000. We also see that N, which is the number of compoundings yearly, is 4. We see that the annual interest rate is 4%, which is 0.04 as a decimal. And we also have the time, which is 10, which alludes to 10 years. If we plug all of the given information into the formula, we have the following. I'll simply verify this by putting that into my calculator. So we have 1,000, which is the principal, times 1 plus 0.04 divided by 4. I'm going to close off my set of parentheses, raised to the 4 times 10 power. And we have an accumulated amount of $1,488.86, which would be our final balance after 10 years if no withdrawals are made. Next, let's take a look at continuous compound interest. If an amount of P dollars is deposited at a rate of R, which is in decimal form, and is compounded continuously for T years, then the final amount in the account after T years is given by the following formula. A is equal to P times exponential E raised to the R times T power. And in the next slide, we'll talk more about this exponential E. As far as my calculator is concerned, the exponential E is built into the calculator. From this given formula, we see that P is the principal or the initial investment. We see that R, once again, is the annual interest rate, which is in decimal form. E is exponential E, which carries a value of 2.71. And we have the time in years. The natural number E was named after Leonard Euler, and it involves this expression 1 plus 1 divided by k raised to the power of k, and as x approaches infinity, this value for E approaches 2.718 approximately. Another fact about E is an irrational number, which means that the decimal never stops and it never repeats. E is also an important base because calculators are programmed to find the powers of exponential E. So let's take a look at an example. Suppose $5,000 is deposited in an account paying 3% compounded continuously for 5 years. Find the total amount of deposit at the end of 5 years. Here's the solution. From the given information, we're going to pull out the principal, which is $5,000. The annual interest rate is 3%, which is 0.03 as a decimal. and our time is 5 years. Once we plug all of the given information into the formula, we have an accumulated balance of $5,809.17. To verify this in the calculator, I'm simply going to put in my principal 5,000. My exponential E key is above my natural log key, so I'm going to hit second and natural log, and it brings up the exponential E key. I'm simply going to put in 3%, which is 0.03 as a decimal, times our time, which is 5, and it gives us an accumulated balance of $5,809.17. Thank you for watching.